How does Node.js actually work? Well, it's built on top of Google's V8 engine, which is written in C++. It also comes with a JavaScript runtime that allows you to run your code outside of a browser environment. It gives you access to the operating system and other resources so you can build all sorts of awesome things like web servers, command line tools, and even desktop applications. The callback function is like a block of code that gets executed when something interesting happens. In this case, it's when a client connects to the server, the callback function runs the HTTP response write head and then the HTTP response write. Instead, it emits an event that gets handled by the callback function. It's an event-driven, non-blocking I/O model that allows developers to write fast and scalable server-side applications. Now you know how to impress your friends with your newfound knowledge of Node.js. This allows other tasks to run while the request is in progress. These two functions send a response back to the client. The write-head function sends the status code and some headers, and the write function sends the actual body of the response. That's where the magic happens. It's just like Chrome uses the V8 engine to run JavaScript on your browser. It just sends the request and then moves on. This allows Node.js to handle a large number of concurrent connections without blocking. Node.js uses it to run JavaScript on your computer. Now, the V8 engine is an interpreter, which means it reads and executes your code line by line, but Node.js doesn't stop there. But how does Node.js handle multiple concurrent connections at the same time? We can use the built-in events module to handle these tasks. The events module allows us to perform operations that take an unknown amount of time without blocking the event loop. How does it handle all those different events? Let's take a look at this example. We have a simple HTTP server that listens on port 3000. When the server starts, it creates a pool of worker threads. These worker threads are like little processes that sit around waiting for something to happen. They sit around and they listen for incoming connections on the port. Once a connection comes in, they execute the callback function. Now this is all happening asynchronously. The worker thread does unwait for the response to finish sending before moving on to the next request. But what if we want to do something more complicated, like read a file or make an HTTP request to another server? When the worker thread makes an HTTP request, it doesn't wait for the response to come back. So that's how Node.js works in a nutshell.